Assalamualaikum and hi. We are from Group 4 and today we will present our statistical analysis entitled Bank Loan Approval Analysis. This study analyzes a bank loan dataset to understand the demographic and financial characteristics of applicants and examine factors associated with loan approval decisions. Our group consists of five members, which is Zarul Zakwan bin Zakaria, Muhammad Nur Alif bin Nur Azman, Abdul Qawi Haziq bin Abdul Haq, Muhammad Naqib Imran bin Abu, and me, Muhammad Afif Daniel bin Rahim. So now I will present our background of the study. So, banks, as you know, receive many loan applications every day from individuals with different financial backgrounds. Before approving a loan, banks evaluate several factors such as income, education level, number of dependents, credit history, and also property area. Understanding these characteristics helps bank make fair and accurate lending decisions while reducing financial risk. So, statistical analysis allows bank to identify patterns and relationships among applicant characteristics which can improve the efficiency and consistency of the loan approval process. So, loan approval is one of the most important decisions made by financial institutions. Every applicant has different demographic and financial characteristics, which is bank needs to evaluate this characteristic carefully before approving a loan. Therefore, this study used statistical analysis to better understand these characteristics and support more effective loan and also approval decisions. So, the problem statement is banks often receive a large number of loan applications with different applicant profiles. It can be challenging to determine which factors influence loan approval. Without a proper statistical analysis, decision making may become inconsistent or inefficient. Therefore, this study investigates whether certain applicant characteristics are associated with loan approval decisions. Although banks now have their own approval procedures, it is still important to identify which characteristics are related to loan approval. This study focuses on analyzing applicant information to support more objective and data-driven decision making. Moving on, there are three objectives of our study. The first one is to describe the demographic and financial characteristics of bank loan applicants. Second, to determine whether the mean loan amount differs across different numbers of dependents. And the last one is to determine whether the property area is associated with the loan approval status. Next, the study provides several benefits such as help banks understand applicant characteristics, support better loan approval decisions, reducing lending risk, improve efficiency in evaluating loan applications, and provide useful information for future banking research. These objectives allows us to understand the profile of bank loan applicants and examine whether certain variables influence loan approval decisions. The findings also can assist banks in improving their lending strategies and making more informed decisions in the future. Next, for the methodology, this study used secondary data that obtained from Kaggle. The dataset contains information from 614 applicants and includes demographic, financial, and loan related variables commonly used by banks during the loan approval process. Moving on to the method of analysis, different statistical techniques are selected based on the research objectives. Descriptive statistics summarize applicant characteristics. One-way ANOVA compares average loan amounts among different dependent groups, and the chi-square test determines whether there is an association between property area and loan approval. So for this study, SPSS was selected because it is widely used in academic research and provides reliable statistical tools for analyzing both descriptive and inferential statistics. The software also generates clear tables and outputs for interpretation.
Now, I will present Objective 1, which focuses on the descriptive statistic of the bank loan applicants based on three variables: applicant income, loan amount, and credit history. Let's begin with applicant income. There are 614 valid observations for applicant income. The monthly income ranged from 150 to 81,000 with an average or mean income of 5,403.46. The standard deviation is 6,109.04, indicating a wide variation in applicants' monthly income. This suggests that the dataset includes applicants from both low income and high income group. Next, let's look at the loan amount. There are 592 valid observations for loan amounts. The requested loan amount ranges from 9 to 700 with a mean of 146.41 and a standard deviation of 85.59. This indicates that although the average loan requested is approximately 146, applicant requests a wide range of loan amount. Moving on to credit history, there are 564 valid observations for credit history. The variable is coded as 0, which means no credit history, and 1, which means positive credit history. The mean value is 0.84, indicating that approximately 84% of applicants have a positive credit history. The standard deviation of 0.365 shows relatively little variation because this is a binary variable. Finally, let's look at the valid end listwise. The valid end listwise 543 means that 543 applicants have complete data for all three variables: applicant income, loan amount, and credit history. The remaining observation, which is 71, contain at least one missing value. So, the summary is the descriptive statistics show that applicants have diverse income levels and loan amount, while the majority of applicants have a positive credit history.
Hello, my name is Muhammad Nur Alif bin Azman. A total of 614 loan applicants were recorded in the dataset. Among them is 489 applicants, is the 79.6 percentage were male, while 112 applicants, 18.2 percentage were female. The remaining 13 applicants, 2.1 percentage had missing or unspecified gender information. This finding indicate that the majority of loan applicants were male, accounting for nearly 4/5 of the total sample. This suggests that male applicants were significantly more represented than female applicants in the dataset. Among the 614 loan applicants, 398 applicants, 64.8 percentage were married, while 213 applicants, 34.7 percentage were unmarried. The remaining three applicants, 0.5 percentage had missing marital status information. This result indicate the majority of applicants were married, representing nearly two-thirds of the total sample. This suggests that married individuals constitute the largest group of loan applicants in the dataset. Among the 614 loan applicants, 480 applicants, 78.2 percentage were graduates, while 134 applicants, 21.8 percentage were non-graduates. This finding indicate that the majority of applicants possess a graduate level education, accounting for more than three quarters of the total sample. This suggests that the applicant pool was generally well educated, while graduates representing the dominant educational group. Next, out of the 640 loan applicants, 500 applicants, 81.4 percentage were not self-employed, while 82 applicants, 13.4 percentage were self-employed. The remaining 32 applicants, 5.2 percentage had missing employment status information. This finding indicate that the majority of loan applicants were salaried employees rather than self-employed individuals, accounting for more than 4/5 of the total sample. Next, among the 640 loan applicants, 345 applicants, 56.2 percentage had no dependents, 102 applicants, 16.6% had one dependent. 101 applicants, 16.4% had two dependents, and 51 applicants, 8.3% had three or more dependents. In addition, 15 applicants, 2.4% had misinformation regarding the number of dependents. This finding indicates that more than half of the applicants did not have any dependents, while the remaining applicants had one more or more dependents. This suggests the applicants without dependents constitute the largest group within the dataset.
So let's move on to property area. Among the 614 applicants, there are 179 applicants, which consists of 29.2% are from rural areas. Next, 233 applicants, which consists of 37.9% are from semi-urban areas. And lastly, 202 applicants, which consists of 32.9% are from urban areas. Therefore, the highest proportion of applicants are from semi-urban areas, followed by urban areas, while rural areas account for the smallest proportion. Moving on to loan status, among the 614 applicants, there are 192 applicants, which is 31.3%, had their loan application rejected, or and 422 applicants, which consists of 68.7%, had their loan application approved, which is why, therefore, more than two-thirds of the applicants had their loan application approved, while less than one over third had their application rejected.
Next, I present objective 2. So our second objective is to determine whether the mean loan amount differs across applicants with different numbers of dependents. To answer this objective, we use a one-way ANOVA because we are comparing the mean loan amount among more than two groups of dependents. The independent variable is the number of dependents, while the dependent variable is the loan amount. So as you can see from the ANOVA table, the ANOVA result is the F value is 5.421 and a P value of less than 0.001. So since the P value is less than the significant level of 0.05, thus we reject the null hypothesis. This means that there is a statistically significant difference in the mean loan amount among applicants with different numbers of dependents. However, ANOVA only tells us that a difference exists. To identify which specific group are different, we perform a game-Howell post hoc test. It was shown in the next slide. So now I'll explain the hypothesis testing and the post hoc result. So for the step 1, we determine the hypothesis. So the H null hypothesis states that the mean loan amount is the same for all dependent groups. For the H1 hypothesis, it states that all at least one group has a different mean loan amount. Next part, step 2, we determine the alpha and the p-value. So the alpha is 0.05, where the p-value equals to 0.001. For step 3, since the p-value 0.001 is less than alpha 0.05, we reject the H null hypothesis. So for the result, it shows that there is sufficient evidence to indicate that the mean loan amount differs across different number of dependents. So for the conclusion, at 5% significant level, the mean loan amount significantly differ across different number of dependents. Therefore, the number of dependents has a significant effect on the loan amount. So for the last part is the post hoc test. According to the table before, the game's Howell post hoc test shows that only one comparison is statistically significant, which is between applicants with one dependent and those with three or more dependent. The mean difference is negative 62.513. It shows that The applicant with one dependent receive on average about 62.5 unit lower loan amount than the applicant with three or more dependents. All the other comparisons should have p-value greater than 0.05. So there is no statistically significant difference between those groups. So in conclusion, the one-way ANOVA shows that loan amount differ according to the number of dependents. Based on the post hoc analysis, the significant difference exists only between applicant with one dependent and those with three or more dependent, while the remaining group have similar mean loan amount.
So next, I will present objective 3, which is the inferential analysis. The objective of this analysis is to determine whether a property area is associated with loan status using a significance level of 0.05. Since both variables are categorical variables, we use the chi-square test of independence. The first variable is property area, which consists of rural, semi-urban, and urban. The second variable is loan status, which consists of approved and rejected. From the case processing summary, there are 114 valid cases representing 100% of the data. With no missing values, therefore, all 114 observations were included in the analysis. Next, we look at the cross-tabulation table. From the table, applicants from semi-urban areas have the highest number of approved loans with 179 approvals, followed by urban with 133 approvals and rural with 110 approvals. However, this table alone cannot determine whether there is a significant association. Therefore, we proceed to the chi-square test. So, the chi-square test consists 5 steps. Step 1 is hypothesis. The null hypothesis, H null, states that there is no association between property area and loan status. The alternative hypothesis, H1, states that there is an association between property area and loan status. Step 2 is the significance level. The significance level is alpha equals to 0.05. The degrees of freedom are calculated as 3 minus 1 times 2 minus 1 equal to 2. Because property area has 3 categories and loan status has 2 categories. Step 3. From the chi-square table, the Pearson chi-square value is 12.298 and the p-value is 0.002. Since 0.002 is less than 0.05, the decision is we reject the null hypothesis. Finally, on the conclusion, there is sufficient evidence to conclude that there is a significant association between property area and loan status.